Take a minute of your time and imagine the world without mathematics. Teaching platform, this is Mr. Mlonga, aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome. Please subscribe so that every time we post a video, you are the first to be notified. We'll be posting videos every day. Today I want to talk about a subtopic of algebra, and this subtopic is called difference of two squares. In this case, you are asked to actually simplify 4m to the power 2 minus 9 over 4m minus 6. When you are dealing with such a question, look at what you have in both the denominator and the numerator as you go towards the solution. So in this case, this is 4m to the power 2 minus 9. This 4 is a perfect square. This 9 is a perfect square. So we can write this one in index form and also this one in index form. That is for the numerator. Let's do that. This 4 can be written as 2 to the power 2, then m to the power 2, minus. This 9 can be written as 3 to the power 2, then over. What about what we have in the denominator? This is 4, it's a perfect square. But this 6 is not a perfect square, and this m is not raised to the power 2, so we'll not go this route. Look at it again. There is a common factor, hence you can factorize in the denominator. 2 into 4 is 2, so you write the 2 outside. 2 into 6 is 3, so here the 2 is already outside. Then what do you remain with there? That is a 2, then m minus 2 into 6 is 3, so you have a 3 in that position. Then at this point, you cannot factorize any further in the denominator, but you can factorize more in the numerator. This is a difference of two squares because it can be written as 2m in brackets to the power 2 minus 3 to the power 2 over 2m minus 3, like that. When we say difference of two squares, it means two terms that have been raised to the power 2 are being subtracted. So difference means subtraction. Square means power 2. From there, you can now factorize a difference of two squares. When you're factorizing a difference of two squares, what you do is you open two pairs of brackets like that. In the first bracket, you write this 2m minus this 3, write a 3. In the second bracket, you write the same 2m, but in this case, plus 3. Then over 2 open brackets, 2m minus 3. At this point, is there anything that we can factorize further? Nothing. So at this point, what you can do is you look at the common factors in the numerator and also in the denominator. This 2m minus 3 is common, so it can cancel with that one. Then what are you going to have? You are going to have a 2m plus 3 over 2 as your final answer. This is the answer that we are looking for. At this point, you have simplified and you cannot go any further. There's nothing to add, there's nothing to divide. We can have another question coming from the same, so that you can have a better understanding of what we are trying to do here. So to have another question here, another question, let's say 2x to the power 2. Let's say this was, let this be b. So 2x squared minus 8 over x plus 2. Looking at what we have here, there's nothing we can do in the denominator. Is there anything we can do in the numerator? Of course, yes. 2 is common, so we factorize. We start from there. We say 2 is common. We write it outside brackets. When this 2 is outside brackets, we remain with x to the power 2. minus 2 is outside, so 8 divided by 2 is going to be a 4, like that. Then over x plus 2. What else can we do? There's nothing to cancel here, but can we factorize any further? Yes, we can factorize further if we write this 4 in index form, because this is a perfect square. So we have this is equal to 2, which is this 2, open brackets, x squared minus, write this one in index form, it will be 2 to the power 2, like that. Then you have x plus 2. X plus 2. At this point, is there anything to cancel? Nothing. Is there anything to factorize? Yes, this is a difference of 2 squares. So you have 2, open brackets, open another bracket, then you do this, then x plus 2, like that. It's okay, even if you write it in brackets or not, it's okay. Then from there, when you have to factorize a difference of 2 squares, write the difference of the bases in the first bracket. So you say x minus 2. This is the difference of the bases. Then sum of the bases is going to be x plus 2, like that. So in the first bracket, you write the difference of the bases. In the second bracket, you write sum of the bases. At this point, is there anything you can factorize any further? No. Are there any common factors considering the denominator and the numerator? Yes, this is x plus 2, and that is x plus 2. So this is 1. Hence, you have the answer 2, then x minus 2 over 1. You ignore the denominator 1, so the answer is just 2, open brackets, x minus 2, like that. This is the correct. And in this case, our task is to simplify each of the following. We have 2 questions here, question A and question B. So to start with A, solution. For A, solutions. In the numerator, we have x minus 1. These, they cannot be added or subtracted, and there is no way of factorizing them. They will just remain like that. So there we maintain x minus 1 over x squared minus 1. What can we do there? We can rewrite it as x squared minus 1 to the power 2, because this is still 1, and this makes a difference of 2 squares. Then from there, what can we do next? We can now think of factorizing in the denominator. So this is going to be equal to x minus 1 over, if this is a difference of 2 squares, then you open 2 sets of brackets. In the first set of brackets, you write the difference of the bases. We are talking about x minus 1, that is subtraction of the bases. Then in the second bracket, you write the sum of the bases, meaning x plus 1. The only difference is this is minus, this is addition. Then from there, what else can we do? Is there anything we can factorize here? Nothing. But look at what you have in the denominator and also in the numerator. There's something common, except that in the denominator we have brackets. This is x minus 1, which can go with this other x minus 1. And from there, this is actually going to give us 1 in the numerator, and then x plus 1 in the denominator. We have x plus 1 in the denominator. This is the answer in simplified form. Let's look at what we have for B now. For B, we have x, we have 2x minus 1. There's nothing that can be done on that. They cannot be added or subtracted. So this will still be 2x minus y over, then 4x squared minus y squared. This is a perfect squared number, so it can be written in index form. If it can be written in index form, then we're saying that this is 2 to the power 2, then x to the power 2 minus y to the power 2 equals. I've not changed anything. This is still a 4. So this is equal to 2x minus y over, you can factorize the power on this. So you write 2x in brackets, then to the power 2 minus y to the power 2 like that. When that is done, what else can we do? We can now factorize. Factorization can take place, so we have 2x minus y over, when you are factorizing a difference of two squares, you open two sets of brackets. In the first bracket, you write the sum of, you write the difference of the bases, meaning 2x minus y, not sum. It has to be difference, which is subtraction. Then 2x plus y. The only difference is that this is minus, this is plus. Is there anything we can do any further? If these are in brackets, they will look more like the same, and there's no harm in introducing the brackets. So 2x minus y will cancel with the other 2x minus y, meaning you are remaining with 1 in the numerator, then over 2x plus y, x plus y. This is the answer we are looking for. As simple as this might seem to be, they are very applicable in complex situations. So these are basic concepts that someone needs to know so that they can be applied in more complex mathematics. This marks the end of the lesson. This marks the end of our lesson. Please, if you have not subscribed, this is the time to do so, because every day we'll be posting videos, and it's important that every time we post a video, you are the first to be notified. Where you need to comment, you need to ask something, do not hesitate. We value your support, we value your contribution, be it positive or negative. Welcome once more, and thank you very much for having watched the video. Please share the video with others. Let other lovers of mathematics enjoy the mathematics that we are doing on this platform. It's mathematics all the way until Jesus Christ comes. Take a minute of your time and imagine the world without mathematics. We cannot be able to calculate or count the time without the use of mathematics. The calendar that we use is a product of mathematics. We only get to know that this is the year 2020 by the use of mathematics, by following the calendar mathematically. The population of any country is a product of mathematics. You only get to know that it takes 9 months for a baby to be born through the use of mathematics. In the medical field, temperature is calculated using mathematics. In the business world, profit and loss is only appreciated by the use of mathematics. A bricklayer uses mathematics to calculate the number of bricks needed for that construction. A carpenter uses mathematics to calculate the gradient of the roof before the roof is put up. A policeman has to count the number of prisoners in that police cell through mathematics. A thief should be able to calculate the hypotenuse of that brick wall before falling off that brick wall. We all need mathematics. Mathematics runs the world.